The purpose of this video is to help you understand how to find the missing angles of a right triangle when you know two of the three sides. So to start with, here's what we know so far. If you look up at the top, if you know that you have a reference angle in a right triangle, then you can use a trig table to find the opposite side divided by the hypotenuse written as a decimal. So you can see I have my triangle, I circled the reference angle, I have my hypotenuse and adjacent, the remaining side is the opposite. So in this problem, I know the opposite is 10, and I know the hypotenuse is the variable that I'm looking for. So when I go to write the equation, opposite and hypotenuse is going to give me sine. So my equation is right here. The sine of 17 over 1 equals 10 over x, the opposite over the hypotenuse. So in this case, I know the reference angle is 17, and I know that there is only one possible combination of opposite over hypotenuse that goes with a 17-degree angle. And I can find out the decimal version of that opposite divided by hypotenuse by looking at the trig table. So if I look at 17 degrees, I know that the opposite over hypotenuse is 0.9 or 0.2924. So 0.2924 is going to equal 10 divided by whatever my hypotenuse is. And I can solve that equation to find that. Now, what you guys have been practicing doing is using your calculator. So the first thing when we go to our calculator, we have to be sure that we're in degree mode. So if you don't see a D there, press Shift and then Setup, and then pick choice number 3, which will put your calculator in degree mode so that your calculator knows that in this math class for this type of problems, angles are measured in degrees. So to solve this problem, the x is on the bottom, so I'm going to use the commutative property to switch these. Sine 17 times x is the same as x times sine 17. So what I really need to do is I just need a 10 on the top and a sine 17 on the bottom. And when I press equals, it tells me that that's going to be 34.2030, which, as you can see in my second triangle, I have already figured that out. So the opposite 10 over the hypotenuse, 34.2030, comes out to this decimal, which that decimal only matches up with the sine of 17. So now when I go to my second example right here, it's the same problem, but the opposite is where the variable is, and the hypotenuse is the side that I know. It's still a 17-degree angle. So my equation is going to be sine of 17 over 1 equals the opposite over the hypotenuse. And so this time, to solve the problem, I don't need to use the commutative property. I'm just going to multiply x times 1 and get x, and multiply 34.2030 times the sine of 17. So on my calculator, I just need to type in 34.2030 and then sine of 17. And when I press equals, it comes out to 9.999989417, which obviously is going to round off to 10, which is the same value that we got for our 17-degree right triangle in the first problem. So here's where we make the big logical switch to learning something new. We have known the angle, and there is only one decimal that can possibly match up with that angle. Today, we're going to do the inverse of that. If you know the opposite side divided by the hypotenuse written as a decimal, then you can use a trig table to find the reference angle in that right triangle. So on this problem right here, it's the same triangle. There's our opposite, which is 10. There's our hypotenuse, which is 34.2030. And if I change the opposite over hypotenuse to a decimal, the opposite over hypotenuse to a decimal. So I'm going to clear, and I'm just going to take my opposite, 10, divided by my hypotenuse, which is 34.2030. And when I change that fraction, 10 over 34.2030, into a decimal, the decimal is 0.2924 if I round it off. So if I look in the sign column and I try to find that decimal 0.2924, that decimal shows up right here, 0.2924. And the only angle that can have that decimal when you divide its opposite and adjacent is a 17-degree angle. So we found out that this angle is 17 degrees by looking up the decimal for the opposite divided by the adjacent in the sign column. And then we went over and we found out that that is at the 17-degree row. So we were able to use the two sides of the right triangle to find the reference angle in that triangle. That's something new. This is what the equation would look like if you wanted to write down the equation. The equation is the sine of x over 1. Normally we put the reference angle after the sign in parentheses, but now we're putting our variable after the sign in the parentheses because we don't know what our angle is. And instead of having an x for our opposite or an x for our hypotenuse, we know both the opposite and hypotenuse. So now the only variable in our equation is the angle. On this slide, we're going to start exactly where we left off on the last slide. If you know the opposite side divided by the hypotenuse written as a decimal, then you can use a trig table to find the reference angle in a right triangle. So here's our 10 for our opposite side, our 34.2030 for our hypotenuse. There's our angle that we don't know, x. And we did use a trig table to find out that it was 17. This slide is about showing you the steps to using your calculator to find out that the reference angle is 17. And then after this, we'll do a few examples where you can see how to use your calculator to quickly find the missing reference angle. So our equation that we had on the last slide was sine of x over 1 equals 10 over 34.2030. Here's that equation right here. So the first thing that I'm going to do, I'm going to forget about the one on the bottom. So even though this is a proportion, I'm going to rewrite it, and now I'm just going to have the sine of x equals 10 over 34.2030. Step number one. Step number two, I want to get the x by itself. I want to solve this equation for x. So I'm going to divide both sides by sine. So here I have the sine of x divided by sine, and here I have my fraction for my opposite over my hypotenuse, and I'm dividing that by sine. So I divided both sides of the equation by sine. And you can see in the next box, the only thing left on the left-hand side of the equation is x. And that's what I wanted. I wanted to solve for x. The math that makes this happen is I divided by sine. So now I have a sign on the bottom of the fraction right here. And that sign has an exponent, which is positive 1. When I move that sign to the positive 1 from the bottom of the fraction to the top of the fraction right here, notice that its exponent went from positive 1 to negative 1. That's important. You should know that. But what's really important is now, instead of referring to this as the sign, now we refer to this as the inverse sign. And when we want to get the inverse sign on our calculator screen, we have to press an extra button to let the calculator know that we're looking for the angle, we're not looking for a side. And so when we type this equation into our calculator, we're going to end up with x equals 17 degrees. But for this slide right now, I'm about to tell you the most important part. This is how you type this into your calculator. So we're going to press clear. And instead of just hitting the sign button like we normally would, we're going to hit shift and then sign. And notice now, instead of having sine on the screen, we have what's referred to, or what we call, the inverse sign on the screen. Then I hit the fraction button. On the top of the fraction, I put in 10. On the bottom of the fraction, I put in my 34.2030. I can close my parentheses if I want to. And when I hit the equal sign, it tells me that my angle is 17.00001854, which, if we round off, is going to be 17 degrees. So before we move on to some examples, the most important thing on this slide is that if you want to get the inverse sign on your calculator screen, you don't just hit the sign button, you have to hit shift and sign. And if you look closely at your calculator, you can see there's a little yellow inverse sign right here, and you have to hit the yellow shift button to make the yellow inverse sign work on your calculator. Here's our first example. We have a right triangle, and we are looking for this reference angle. So I circle the reference angle. I highlight the two sides that make up the reference angle. There's the hypotenuse, there's the adjacent, there's the opposite. On this problem, I have an adjacent that's 6.1 and a hypotenuse that's 7. So I need a place to put in the 6.1. That'll be right there on the top. I need a place to put in the 7. That'll be right there on the bottom. So this is a cosine problem. So I write my equation like this. The cosine of the angle, which in this case is x, equals the adjacent, which is 6.1, over the hypotenuse. And now, like on the last slide, I'm going to divide both sides by cosine. And what I end up with is an equation that looks like this. X equals the inverse cosine, and then there's my fraction, 6.1 over 7. That is my adjacent over my hypotenuse. So now when we go to the calculator, here's how I would put that in. Instead of just hitting the cosine button, I have to hit shift and then cosine. So I have my inverse cosine on the screen, hit the fraction button. On the top of the fraction, I put in 6.1. And on the bottom of the fraction, I put in 7. Then I'm going to use the arrow to get out from under the bottom of the fraction, close the parentheses, and when I hit the equal sign, I find out that this angle is 29.37492453. And in the directions on most of the problems in the textbook, when it comes to angles, they ask you to round them to the nearest tenth, which is only one decimal place. So this 7 right here is going to bump the 3 up to a 4. And so my angle, this reference angle right here, is 29.4 degrees. Here's another example. My reference angle is x. Here are the two sides that make up the reference angle. The longer is the hypotenuse, the other one's the adjacent, and the third side is the opposite. So in this problem, I need a place to put my 6.1 in for the opposite and my 8 in for the hypotenuse. So when I look at my SOHCAHTOA, that's going to have to be sine, because it's the only one that has a place for the 6.1 and the 8. So this is a sine problem. So I write the sine of the angle, but the angle this time is our variable. So it's the sine of x equals the opposite over the hypotenuse. Then I divide both sides by sine to give myself x equals the inverse sine of 6.1 over 8. And then I have to put that equation into my calculator. So instead of just hitting the sign button, I have to hit shift and then sign. Then I hit the fraction key, and on the top of the fraction, I put in 6.1. And on the bottom of the fraction, I put in 8. Then remember, you have to hit the right arrow to get out from under the denominator. And then you can close the parentheses, press the equal sign, and we find out that that is the angle right there. But in our textbook, it usually asks rounded to the nearest tenths place. So my 8 right here will bump up the 6 to a 7. And so this angle right here is 49.7 degrees. In this last example that I'm going to do for you today, here's my reference angle. The two sides are the adjacent and the hypotenuse. The remaining side is the opposite. In this case, I need a place to put my 2.6 in for the opposite and my 11.1 in for the adjacent. So this is definitely a tangent problem. So I have the tangent of x equals 2.6 over 11.1 divide both sides by tangent, and I end up with x equals the tangent of -1, or the inverse tangent of 2.6 over 11.1. Now I have to put this into my calculator. So I hit shift and then tangent, and then the fraction button. On the top is 2.6. On the bottom of the fraction is 11.1. I get out from under the denominator, and I end up with 13.18296516. And if I round that off, the 8 will round up the 1. So this is a 13.2 degree reference angle right here. Find the measure of the angle. Number 5, find the measure of the angle. Number 6, find the measure of the angle.